Now I want to do 9 for number 9, primarily because it looks like it's a handy problem to know how to do. So it says a simple random sample of size n is drawn from a population that is known to be normally distributed, right? We still got to have that. Chapter 8 says you can't live without it, right? Unless they tell you it's normal, or if they give you a big enough sample size, or they give you a normal probability plot somewhere. You got to have one of those three things. All right, so the sample variance s squared is determined to be 12.6. Ooh, that sounds like something I should be typing. S squared, that's 12.6. That's the sample variance. And then it tells us n is 20. Oops, 20. And it tells us our confidence level. Our confidence level is 0.90. All right, so then what's alpha? Alpha is 1 minus that. Alpha over 2 is that value we just found in cell B4 divided by 2. 1 minus alpha divided by 2 is equal to 1 minus that. Now again, if you want to insert the Greek symbols, you knock yourself out. We should also figure out our degrees of freedom, handy thing to know, which is n minus 1. So in this example, it's 19. All right, then we need our chi-square critical value. So we need the alpha here, crit value for alpha over 2. That's going to be equal to 1, chi inverse. Probability is the alpha over 2, that's this one, 0.05, comma, degrees of freedom, 19. And then let me drag this because I want the same thing basically for the next one. 1 minus, oh, don't you love it when Microsoft thinks they're smarter than you? I want alpha over 2, not alpha over 3. So that would be chi inverse. And then this is probability is 1 minus alpha over 2, that's the 0.95, comma, degrees of freedom is 19. There we go. All right, so what's the lower bound for sigma squared? Okay, that's the formula back here. Let me show it to you right here. So this is the confidence interval for sigma squared, for the variance, right? The lower bound's this and the upper bound's this. So let's go look at ours. Lower bound is supposed to be n minus 1, that's your degrees of freedom, 19, times s squared, that's up here, 12.6, divided by the chi-square for alpha over 2. That's this one right here. There's your lower bound. Upper bound for sigma squared. That would be equal to, oops, you can't see it. There it is. N minus 1, that's 19, times s squared, that's 12.6, divided by, if I could type correctly, divided by the 1 minus alpha, that's the 10.117. And there we go. We have our bounds and everything. Groovy. Let me show you a few more things before we head away. So this is the answer for part A, just so you can see it. Okay. A couple other things. First of all, I want you to know that StatCrunch will also do this problem for you pretty simply. If you go to the book, here I have it open, StatCrunch, and don't pay any attention to this data, we don't need it right now. You go to Stat, you go to Variance, see it right there, Variance. You're doing a one sample. You have a summary. Data is like when you have a column of data like this problem right here. We don't have data for this problem, we have a summary. So I click with summary. It's going to ask us what the sample variance was. That was 12.6, that's s squared. Again, if I could type right. N was 20, that's our sample size. Click next. We want a confidence interval. We want 0.90. Click calculate. And there it is. Copy. Let me print it down here so you can see. Same numbers. There it is, 7.94. See it? 7.94. 23.66, 23.66. It's the same. Okay, so StatCrunch will also find those for you if you like. Another thing I want you to see real quick before we go is that the problem only changes the numbers for parts B and C. So all you'll have to do is copy and paste and change numbers.